Hello everyone. In the previous lecture, we discussed about what are the digital systems, what are the digital signals, and what are the advantages of digital signals or the digital systems over analog systems. We also discussed about uh, uh, how what are the different information that is needed to design in a digital system. Like you must have the information about the input quantities or the input data, output data, and what kind of logic you want to implement. So if you have the knowledge of all these things, definitely we can design any of the digital systems. Suppose we have designed some integrated circuits. So this is really very important to understand how the integrated circuit looks like. Okay, so let us have a quick look of the IC, how it looks like, and what is the meaning of the numbers on it, right? So suppose, yeah, this is the view of the integrated circuit of any of the IC for any particular logic function. If you closely see here, we have a different pins, and all the pins are in the dual inline packaging. Dual inline packaging means the pins are in the lines and the two lines are there. Okay, and there's if you see closely, there's one more difference here. There is one more cut here. What this cut indicates? So the meaning of there is a significant of this, the significance of this cut, as well as the numbers whatever written over here. So let us try to understand one by one what is the meaning of all these things. Okay. First, an important thing that we have to consider, what is the importance of this cut? Suppose if you are observing some cut in any one of the direction, keep it at the top side. Okay, and now start counting the number, start counting the pin from the left hand side and move into the anti-clockwise direction. Okay, so here we have the cut. So this is the pin number 1, this is the pin number 2, this is the pin number 3, 4, 5, 6, 7, then 8, 9, 10, 11, 12, 13, and the 14. So this is how we put the pin number to understand, like, yes, because suppose if I have to design any logic based on this IC, so we should know where I have to give the input, where I have to give the output. So this number is really important. Yes, of course, because to operate these ICs, we must provide some supply voltages. So at which in the pin we have to provide the VDD, at which point we have to connect it to the ground. So this is decided by the pin numbers. So for each IC, this pin number indicate this particular thing. One very important thing, like if you see here, you can see there are some numbers on the IC which is printed at the top of this IC. What is the meaning of this number? Let us try to understand that number as first. So if you see, the number is something like HD74 LS00P. So let us understand one by one what is the meaning of all these things. Okay, so let us first start with the first two letters, whatever we have. This is the HD. Okay, this this first two letter indicates that this is the company code, like which company has fabricated this IC. Okay, so who has developed this IC? This is indicated by the first digit. So this first two digit is nothing but this is the company code. Okay, so this is the company code. Okay, the next two digit, if you see here, the next two digits are these are basically utilized to indicate what is the what kind of IC it is. Okay, so because see, any of the IC can be utilized for two purposes. Either it is for the commercial purpose or it could be for the military purpose. So this second, the next two letters that indicate the IC is for commercial or it is for the military purpose. If, because see, for the commercial purpose, generally we consider the positive temperature, like from 0 degrees centigrade to, let us say, 90 degrees centigrade. But if I'm considering the military purpose, In that case, temperature can be from some extreme negative to extreme positive temperature, because those ICs can be utilized for the military application in the extreme weather conditions. Okay, so the two kind of ICs we need to develop. One is for commercial, and the second one is for the military purpose. So this 74, like the code which is the second and third and fourth digit, that indicates the type of IC which we have. Okay, so this indicates the type of IC. Okay, if 74 is here, like if 74 is written, what it means? It means this is the commercial one. Okay, so this is applicable for the commercial. Okay, and if 54 is there, it indicates this can be utilized for the military purpose. Okay, so this is how this third and fourth digit represents the IC parameter. Next two digit is indicates like what is the technology that is used, okay, to develop or to fabricate this IC, because we must you may have heard about transistor logic, CMOS logic, emitter coupled logic, Schottky, low power Schottky. So these all are the technology that can be utilized to fabricate any of the IC. So these two digits, like LS, which is here, like fifth and sixth digit, that indicates which of the technology is used, which of the logic type, what is the logic types. So technology or logic type, you can say both. Technology or logic type. Okay, so the logic type could be like TTL, it could be like CMOS, it could be like ECL, which is the emitter coupled logic, it could be like Schottky kind of. Okay, Schottky, TTL. So these all are the type of IC or type of the logics or the technology. So there could be different kind of technology that is used. So with the help of, yeah, this indicates like low power Schottky. LS means low power Schottky. Okay, so this is what the logic type indicates. The next two digit, if we see the next two digit which we have, that is that indicates what kind of function it will perform. Okay, so this simply indicates the function. Okay, I will tell you about what kind of a different function that can be represented with the numbers. So this is what this indicates the function. So yeah, because this is the 00, so this 00 indicates for the NAND logic. Okay, so for NAND logic, the 00 is used. For other logic, what is used, I will tell you. The last pin which we have, this is basically utilized to which kind of packaging we have. Like this indicates the packaging information. Okay. Okay, so which kind of packaging it has is used, this indicates the last letter, which is P. P here indicates the packaging is of the plastic jacket, plastic packaging. So plastic packaging is used to the shield this integrated circuit. Okay, so this is all about the pin numbers, the code which is written and the meaning of each digit. Okay, because if you see here, the 00 is written here, so 7400 means it is the TTL logic family. TTL, like this is for the commercial one, and this is nothing but this is for the NAND logic. So this IC is nothing but this is the quad 2 input NAND gate. How we are saying this is the quad, I will explain in the next slide. Okay, let us try to see some of the logic functions which can be indicated here. So let us try to see some of the function. Okay, what are those some functions? Let us try to write those things. Okay, the first function, like if the these two codes, like if I'm talking about 00, so 00 indicates, I just told you this is for the NAND. Similarly, like let me write the numbers, like if 00 is there, then this 00 indicates the NAND logic. Okay, this is for the NAND. If 02 is there, then this indicates the NOR logic. Okay, if 04 is there, then 04 indicates the inverter. Okay, see here, Because if you see, currently we have the 14 pin in this IC. Okay, and I just told you the 2 pins are required for the supply. One is for supply and second one is for ground. Okay, so total we left 12 pins. And suppose I have to make 2 input NAND gate or NOR gate. So 2 pins are required for the input and 1 pin is required for the output. So total 3 pin required for each gate. Okay, and total we have a 12 pin left. So we can accommodate 4 inverters. Four NAND gate or NOR gate. So that is why I am saying this is the quad. Quad means we have the four NAND gate or NOR gate logics. Okay, so this 04 indicates, yeah, so this is how we can calculate how many logic gates we can accommodate. Similarly, if I'm talking about the inverter, so total number of pins are 12. So because one input and one output is required for the inverter, so total 6 inverter can be placed inside this chip if I'm talking about the 14 pin IC. So yeah, so this is what is important. Okay, so if 04 is there, then it is nothing but this is for the inverter. Similarly, if 07 is there, so sometimes we need the buffer as well as for to remove the loading effect and other things. So for if the 07 is there, then buffer is nothing but whatever input I am giving, the output will be same. Or for the impedance matching and other things, the buffer is used. Okay, the next one is like, suppose if I have a 08 in the pin number, in the code, then this indicates the end logic. Okay, and similarly for the OR logic, this should be 32. So yeah, so this is all like basic gates which we have considered. For other gates or other kind of logic, the code is different, so that you can check it out, and this is easily doable. So this is all about how the pin looks like and what is the meaning of the number which is written over here, and how to count the pins, and how to decide from where I have to count the pins. If you go into inside of these ones, yeah, this is what it looks from the outside, but internally, because if I'm talking about this IC, this is simply NAND gate IC having 4 NAND gate inside. So how they are placed? So this is how we can say. If you see here, here we have a VDD or VCC at the pin number 14. We are providing the VCC at pin number 14, and we are providing the ground at pin number 7. Now rest, because we have 12 pins left. So, and because this is the quad 2 input NAND gate, so the 2 pins are required for the input and 1 pin required for the output. So that is how the internal structure looks like for the quad 2 input NAND gate logic. So 7400 is nothing but this is how it will looks like. So I have to provide the input at the pin number 1 and the pin number 2, and I have to check the output from the pin number 3. Similarly, the input will be provided at 4 and 5, and output will be taken from the 6, and so on. So this is how it looks from the inside. Yes, if we talk about these logics can be designed with the help of different technologies. Either it could be the transistor logic, it could be the diode transistor logic, it could be the CMOS logic. So this internal structure can be designed with the help of whatever technology we are considering. Okay, so later on I will tell you how we can design a logic gates with the help of MOSFET, with the help of transistors. So briefly I will explain when I will talk about the digital logics. Okay, so this is how it looks like. Now, because if you see in the previous slide here, we are able to integrate 4 number of logic gates. Okay, but what it means, this has a limited scope. It can perform a limited logic because it is only NAND gate, 4 input NAND gate. So it can be utilized for the NAND gate, or after connecting pins here and there, it can provide some Boolean function, or it can be used for a Boolean function. But suppose if I have a more number of functions that need to be embedded in an IC, in that case, the level of integration is really important. Okay, so the level of integration indicates how many transistors we have, how many logic gates we have, and how many functions we can implement out of it. So if the number of transistors are from 0 to 10 and the logic gates are 1 to 12, in between 1 to 12, we call it the SSI logic, or the small scale integration logic. If I want to increase more functions, then I have to move ahead with from SSI to MSI, which is the medium scale integration, having the 10 to 500 number of transistors, whereas 13 to 99 logic gates can be considered under the MSI category. But because the if we are moving towards the recent digital worlds, the number of functions on a single chip are more. We are embedded more number of functions, so I have to increase the number of transistors, number of functions, or the number of logic gate. So we need to consider for the next kind of integration is the large scale integration. Similarly, VLSI, which is really very important, like very large scale integration, having the 20,000 to this much of transistors are there, transistors counts are there, so we can accommodate more number of logic functions. So we don't need to connect many chips. We can perform all the operation in a single chip. So this is the importance of integration. Okay, and similarly we can have one more, like if we have more functions, more number of logic gates, then we can call it the ULSI, which is the ultra large scale integration. Okay, so based on the number of transistors, transistor count, and the logic gates that we have added into it, we can decide what is the level of integration. So this is all about the based on the number of transistors or the density. Some other advanced generation of ICs are like wafer scale integration. What is this wafer scale? Like WSI is nothing but this is the wafer scale integration. If we talk about this, whatever the level of integration we just talked about, wafer is nothing but on which we have to fabricate the chip. We have to fabricate the chip. So on a single wafer, we can fabricate identical chips and several identical chips. So suppose I have a wafer which looks like this one. So this a particular part is a single chip. This is the second chip. This is the third chip. So yeah, so we can have many chips from a single wafer. But if we are utilizing a single wafer for a same IC, like without replicating the IC, and a single wafer, if I am using it as a single IC, so that kind of technology is called wafer scale integration. Okay, so all the logics are placed in a single wafer. Okay, so the more number of functions can be embedded. Same, and the next one is system on chip, like we can embed all the modules, all the blocks in a single chip. Okay, so this is the technology, we call it the system on chip. Third one could be like 3D IC. 3D IC means like if we are stacking the designs and we are connecting in a such a way that the area is less, but we can accommodate more number of function, and we can increase the stacks stack, like we can have a more number of layers in the vertical direction. Okay, so this is also possible, and this kind of technology is the 3D IC. Okay, so yeah, so this is very important, like we should understand what is the level of integration, what are the different advanced generations that need to be considered. So this is all about the some generation of ICs. So basically we will start with the digital design introduction, how to design the digital systems. And to design a digital system, we must know what are the different number systems and different codes, binary codes or other codes, which are really important in the digital system designs. And then we will talk about the different logic styles, different logic designs, especially like different logic gates, combinational circuits, sequential circuits. What are the difference between combinational and the sequential circuits? So these all things we will discuss in the basics of digital logics. Then we will talk about, we will briefly discuss about how to design the combinational circuit, and how we can say this particular circuit is the combinational circuit or this is the sequential circuit. What is the basic difference between these two kind of logics? So we will also discuss these things, and we'll try to differentiate, we'll try to design different kind of combinational and the sequential circuit based on the truth table or based on the input and output patterns. Suppose if I have an input pattern and if I have an output pattern, and I want, based on this input and output patterns, if I want to design some combinational circuits, then we will try to design that part as well. Okay, and similarly for the sequential logic circuit. And then we'll talk about different finite state machine in the sequential circuits. What is the difference, like what are the different kind of finite state machines, what is the use of those machines, and how we can draw the different flow for different kind of
finite state machines. So we'll discuss those things as well. Then we'll talk about the memories. Memory is simply which can store some data, like register is one kind of memory. Flip-flop is one kind of memory which can store a single bit information. What is this flip-flop? I will tell you in more details later on. Okay, so the basic building block for a memory is nothing but this is the flip-flop. Okay, and a combination of flip-flops that can make the register. And if we can increase the size of registers, that can become the memory. So memory is nothing but this is the combination of some digital circuits only. Okay, how to design those circuits we'll discuss in details later on. Then we'll talk about some programmable logic circuits, because suppose I have a digital circuit. If I have designed any digital circuits based on the input and output patterns, so that circuit will work based on whatever the logics we have. But if I have to design any generic circuit, and that can be programmed based on our requirement, so we need to go with the we need to discuss the programmable circuits. Okay, so the main programmable circuit are something like the programmable array logic, programmable logic array, FPGAs. So all these things comes under the programmable circuits. What is the advantage of this programmable circuit over the normal circuit whatever we have designed? We'll discuss later on in details. Okay. Then the last part will be the microcomputers, where we'll talk about the microprocessor 8085, and we will try to understand what are the different blocks that are present inside the microprocessor. Suppose if I have a microprocessor, in that microprocessor, what kind of different operations we can perform, and to perform all those operations, what are the different blocks that exist inside the processor. So we'll discuss all those things. And also we'll try to consider some of the instructions that are required to perform certain operations. Like suppose I have to add two numbers, I have to subtract two numbers, I have to multiply two numbers. So for all these operations, we must have some instructions that we need to provide to the microprocessor. So we'll also discuss about all those instruction set as well in the microcomputers. So this will be the detailed topic which we are going to cover in this particular course. Okay, once you will complete this particular course, then there may be certain objective behind this course, like what should be the different objective. So some of the objective will be like to understand the number representation in the digital systems. Like suppose if I'm talking about the digital system world, in that case, how we can represent the information. So to represent the information, we must follow certain number system representations. So we'll talk about binary number system, decimal number system, octal number system, hexadecimal number system. And other than this common number system, we'll also talk about some other number systems as well. And we'll discuss what are the advantages of those number systems, what is the use of those number systems, and how we can convert from one number system to another number systems. So this will be the first objective, because see, if I'm discussing any digital system or any of the microprocessor, so to discuss any processor, we must know, because all these processors are deal with the digital data. Okay, because all the information which we are giving, that is in the form of digital 0 or 1 only. Okay, so we must know the different number system representations. Okay, the next objective will be like how the combinational circuit works, how we can design the combinational circuits, what are the different process by which we can design the combinational circuit. Based on our input and output patterns, we have to design the combinational circuits. Okay, then the next objective could be like how we can design the sequential circuit based on the input or output patterns. Sequential circuit means, suppose if there is some storage element, then we can call them as a sequential circuit. Like if there is some feedback path between input and output, or output is sampled into the input side, then we can call them the sequential logic circuits. Okay, so we'll also discuss about the sequential logic circuit and different state machines. Then we'll talk about, suppose if I'm talking about the sequential circuit, the memory is the important part in any of the processor, because nowadays memory becomes one of the prime concern. Like most of the people used to search like how much memory we have in our system. Like to store any data, we must have a sufficient memory. So the understanding of memory is also equally important, other than the logics which we are considering here. Okay, so we'll talk about the memory, its classification, and we'll also talk about how we can design those memories based on these digital systems. Okay, then we'll talk about the programmable logics, like without till now we'll understand how the non-programmable kind of circuits can be implemented, but sometimes we may need some programmable kind of circuits where we can program based on our requirement. Okay, so we'll talk about the PLA, PAL, FPGAs and other things. And then the last part will be like whatever the circuits we have discussed here, like combinational circuit, sequential circuit, actually while fabricating any chip, how these circuits are fabricated. Like, see, the important thing is, like, if we are talking about small scale integration, which we discussed in the previous class, like small scale integration, medium scale integration, large scale integration, very large scale integration, we discuss all these things. And the scale integration, that depends on how many transistors we are going to accommodate, or how many logic gates we are going to accommodate. So based on that, we decide what is the integration level. Suppose if I'm talking about the large scale integration or very large scale integration, where number of transistors are very large. Okay, so it is very difficult to connect individual transistor to make a logic. Okay, so to overcome that problem, we must come with some hardware description language. Okay, so some of the hardware description languages are VSDL and the Verilog. So VSDL and Verilog, we just write in just like a C++ coding, and that coding will act as like, once we have executed this one RTL level design, that will act as a transistor kind of circuits. Okay, transistor or logic gates. So all the logic gates, you do not need to connect the individual transistors. We need to write a script based on our requirement, input and output pattern in this VSDL and Verilog, and that will act as the script for that logic. And then once it will be converted into the GDS, then it will become the chip. Okay, so all these things, what the funny words I'm saying, like RTL, GDS, these all things will be discussed when you will go into the next semester, when I will teach about the VLSI subject. Okay, so there I will discuss more. I will be discussing about all these things in more detail. If we talk about this VSDL, right, what this VSDL means, the full form of VSDL is nothing but this is the if you see the full form of this VSDL, this is not the complete one. So this VSDL is nothing but this V instant for VHSIC. So V means VHSIC and HDL means hardware description language. Okay, so hardware description language means what? Whatever the hardware we want to implement on the IC, for that hardware, we have to write one description language. We have to describe that hardware. So that is why we are calling it HDL, hardware description language. Now the question is, what is the meaning of this V? V means, like, the full form of V, V means very high speed integrated circuit. Okay, so again this VHSIC is very high speed integrated circuits. So the exact full form of this VSDL is like very high speed integrated circuit hardware description language. Okay, so these things we will discuss later on when I will teach about this VSDL and other things. Okay, now the next thing which we are going, like, once you will be able to understand all these things, the outcome will be like you will be able to understand the fundamental concept of the digital electronics. You will also be able to understand the different number systems, its application in the digital system designs, and you will be able to understand the combinational and sequential circuits. Then you will be able to apply those sequential and the combinational circuit for a particular applications, like counter designing, to store the data, to design a memory element. So this all things you will be able to understand. And then you will be able to understand, suppose if I have designed some circuits, so there could be some problems, like some hazards, like it's not necessary whatever the input you are giving that you will get the output exactly. There could be certain problems, okay, because of the mismatch, because of the delay. So you will be able to understand how we can remove those hazards. Okay, so we will talk about those hazards as well. So this is all about that you are going to understand uh, uh, about this course. And once you will be able to understand to detect the hazards, you will be able to overcome those hazards as well. So this is all about the outcome of this particular course. Now, once you will go through this course, you will be able to learn about uh, understanding, designing, and optimizing the digital circuits for various quality matrices. The first matrix will be minimizing the function. Suppose, what is the important, what is the meaning of this one? Suppose I have an input function and I have an output function. Okay, and I want to design any digital systems. Okay, so any digital system based on the input and output pattern, I can design in different way. But which one of the way is the optimum way where I need less number of transistors or less number of gates? So the minimization of functions to execute the same logic is really very important. So you will be able to understand how we can minimize the function without changing, without altering the function. Okay, so this is one of the things that you will learn from this course. Second thing I just told you, because if we are minimizing the function, definitely the number of gates will also be reduced. Okay, so how we can minimize the function and how we can reduce the gate to execute the same function, that you will be able to understand out of this course. Then one very important thing, like the delay is the important parameter. Whatever the logic function we are designing, suppose whatever the gates we have implemented, all those logic functions, all those gates have certain delays. Okay, so how we can optimize the delay so that the performance of that complete function, complete system should be very fast, or the delay should be as small as possible. So the time constraint must be taken care, especially if I am designing any digital system. So you will be able to understand how we can optimize the timing issues so that the performance will be better for any digital systems. And the last parameter, you will be able to understand how effectively we are able to design any circuit. I just told you, any of the system or any of the logic can be designed in a different way. But what is the effective way to design, how we can optimize in all the way, like number of transistors, number of gates, number of functions, the less delay. So effective designing is the important consideration, especially if, see, designing is not a problem is like how effectively we are designing that circuit. Okay, so once you will go through this course, you will be able to design your circuit very effectively. So this is the learning outcomes out of this course, because this course is the fundamental course for the people who want to explore their career in the VLSI industry or the semiconductor industry. So this course is really very important. Okay, so you should understand all this concept and all the fundamental which I will teach throughout this semester. So this is all about what we discussed about the digital system. So suppose if I am discussing, I'm considering the digital systems. So might be you're not well aware of what the digital system is. Okay. So if I can recall something from your previous lectures, like previous semester course content, which you have studied in the basic electronics, you may have gone through the topic which we call it MOSFET. Okay, so you know the MOSFET fundamental, FET fundamental, BJT fundamental, all these things, you know how you can design these MOSFETs. Okay, so suppose I had to design an integrated circuit. Suppose let me consider the bigger picture, which is the integrated circuit or the IC. Suppose I had to design an IC. So what are the different abstraction level on which I have to go through so that I will be able to design a perfect integrated circuit? So the lowest abstraction level to design an IC is the devices. Okay, so devices is the basic important feature, important parameter that is really very important. So this device is nothing but this is the MOSFET, transistors like BJT and other things. So this is the the minimum abstraction level, especially if I want to design any digital circuit. Yes, one more important thing, because if I'm talking about the devices, these devices are made of the p-type semiconducting material, n-type semiconducting material. So before these devices, you must know the fundamental of semiconducting materials like p-type material, n-type material, and their properties, and how we can utilize those p and n-type material to design any devices or semiconductor devices. Okay, so you know the p-type and n-type semiconductor material. Based on that, you will be able to design any MOSFET. So this is the minimum or the lowest abstraction level for the IC design or the digital system designs. Okay, once you know the fundamental of this digital system, these devices, you need to create some logic gates. Okay, so the next abstraction level is the minimum circuits. Like here, if you see this circuit, this is nothing but this is the circuit of inverter. Okay, here I have used one PMOS transistor and one NMOS transistor. With the help of PMOS and NMOS transistor, we can create a basic circuit, basic CMOS based circuit. Then we call it the simple inverter circuit. Okay, so the next abstraction level is the basic circuit designing. So once you know the fundamental of devices, you can design the basic circuits. Okay, now once you are ready with these basic circuits, then you can go with some bigger circuit. We call it logic gates. So the basic circuit can be enhanced further to design the logic gates like AND gate, OR gate, NOR gate, NAND gate, any other gates based on their functions. So the next abstraction level for this digital circuit is the gate level designing. Once you are able to design the gate, then the next abstraction for the IC designing will be the module. Module means in a particular module, you can have a different operations like addition, subtraction, multiplication, division, comparator. So all these kind of operations can be embedded into the single module. And these operations, like to execute all these operations, we must consider some logic gates. Based on that logic gates, we can design the module for a particular application. Okay, so this module is designed with the help of gate. So, and these gates are designed with the help of basic circuits, and this basic circuit is designed based on these devices. Okay, so this is how the abstraction works. Now, once you are ready with the modules like arithmetical and logical unit, some storage element, some processing elements, some control units. So after combining all these blocks, you will be able to design a system which we call integrated circuits. So to reach up to integrated circuit, we must know the fundamental of modules, and to know to design the modules, we must know the fundamental of gates, and to design any gates, we must know the fundamental of logic circuits, and and to know the fundamental of this logic circuit, we must know the devices. Okay, and to design these devices, we know the semiconductor materials or material kind of things. So see, IC is not that much easy and not that much difficult. So we must follow each and every abstraction level to reach up to the integrated circuit design or the system design. Okay, so these are the basic abstraction level which we are going to cover in this particular course. We are not going to cover this device part because you have already studied this portion in the basic electronics. We are going to study about this circuit portion. We are going to study about this gate portion, and then we'll talk about some multiplier and divider and something like that. So this kind of block will also be considered. So in this, and then we'll not talk about the system level design. To understand the system level design, we have to go with the VLSI circuit designs course. Okay, so in this particular course, these three abstraction level will be covered. Okay, circuits, gate, and the modules. Okay, so this is all about the different abstraction level for the digital system design. Now, the prerequisite for this course will be the like basic electronics, and yeah, you have already studied this course. So you will be able to understand the basic concept of the semiconducting materials and the semiconductors. And yes, of course, the important prerequisite is interest in this course, in this subject. I will try my best to provide the best content, but the equally important is like you have to create the interest in this particular course so that you will like this course. Okay. Yeah, so this is really important prerequisite. If we talk about the practical and the teaching information, the practical and teaching information, yeah, I will be the course instructor for this course. The practical instructor, I will be again the practical instructor for this course. And the classroom is, yes, unfortunately, it is offline, online class. We have to attend all the courses in online. If we talk about what kind of things we are going to cover in the labs, yeah, lab will be conducted once you will be back in the campus in March. Then the lab will be started. Okay, so but in labs you will be designing some logic circuits, and to design those logic circuits you will use some power supply, multimeter, breadboard, some function generator, oscilloscope, some integrated circuit for the different logic gates, and these kind of things you need to use to design any particular function. Then we'll also talk about, because we will go through the microprocessor 8085. So we will try to design assembly language. We will try to write assembly language program for 8085 microprocessor. And then we'll also talk about VHDL coding with the help of Xilinx Vivado design suite for any combinational or the sequential circuit designs. So these things we are going to cover in this lab portion. Now, if you talk about the class material, yeah, these are some of the textbook which we are going to consider for this particular course. The one subject could be one book could be like Maurice Mano. Second book could be like Malvino Leach, and a third, like for this VSDL, we can consider this J. Bhaskar, and the fourth book for microprocessor, we can consider the Ramesh Gaonkar for 8085 microprocessor. So the fourth book could be like Ramesh Gaonkar for 8085 book content. And the class notes that will be provided and that will be uploaded on the LMS. Okay. And the lab reader, once you will be here, then we can provide the lab manual and other things. Now, this is the important part of this lecture, like evaluation. What are the different components for evaluation? So this is really very important. You should understand how this course is going to be evaluated and what are the different components of evaluation. Accordingly, you can plan your study, right? So we will be having two class tests. One class test will be in the week 3. The weightage of the first class test will be approximately 15%. The second class test will be during the week 8. And the weightage will be like around 15%. We will be having one mid-semester exam in week 5, and the weightage will be around 30%. So if we talk about two class tests in the mid-sem exams, these 3 component or the evaluation component will be in online mode only because this is the during semester. Okay, so these two tests and the mid-semester exam will be in the online mode. Yes, each student will get different set of questions, like the question paper is not common for all the students, so that the plagiarism can be avoided. Okay, so each student will get the different set of questions from the question bank, so be ready for that as well. Okay, one very important thing is end semester exam will be conducted once you will be in the campus. Okay, as per the academic calendar, as of now, this is the plan. So end semester exam will be at the end of this this semester, like in the March only, once you will be here in the campus, and the weightage will be 40%. Yes, we can have a multiple choice question in all these 4 modules, like in 2 tests, 1 mid semester and end semester examination, and the maximum weightage for the MCQ could be 20%, not more than 20%, considering both the test, mid semester and the end semester. So the maximum weightage for the MCQ could be 20%. Okay. One more relaxation can be given to the students. One class test can be converted into the Viva. If you like to give the Viva, definitely. And if you don't want to attend the class test, then you can give the Viva, and based on that we can judge. So this is one of the options. Either you can opt for test 1, or you can opt for test 2. Okay, and you can give the viva, and that will be considered as the replacement of the test. Okay, so this is the option which we can give later on. The important thing is the assignment will be provided after each module. That this assignment will help you to understand this course. Okay, so this is the objective, to give the assignments. Okay, and the tutorial for the problem solving, we have a dedicated time slot for the tutorial. So definitely we'll try to answer, try to come up with some question in each week, whatever we have studied, then that we can discuss in the tutorial lecture. So the tutorial lecture is equally important than the lectures one. Okay, so this is important thing. One very important thing is attendance is really important. Like, see, it is not like you are at home, so you don't have to attend the lecture, you will get the recorded lectures. Okay, I'm keeping record of all the attendance. So the attendance is equally important, and the weightage will be given to the students, to those students who are attentive in the class. And also some bonus points will be given to the students who will ask the question in the classroom. Okay, so more number of questions you will ask, you will get more bonus marks. Okay, so the bonus marks completely depends on how many questions you are asking throughout this semester. So I really welcome the questions from your side. Okay, so that we can make this class interactive. Okay, yes, so this is all about the briefing lectures.